Hi everyone. In this video, we will take a look at how to retrieve data from a database and how to give this data to an LLM, which actually completes the RAG pipeline. And we will do this through this script, which is just for data retrieval. So in order to do this, the first thing we do is we get the collection, which is called publications, which is inside our vector database here. And yeah, you see, this is why we needed the database to be persistent on disk, because this is actually another script that has to read data from disk. So we couldn't have done this if we used a vector database like FIS, for example, which is an in-RAM database. And then after getting the collection, now we will take a look at this function, which is retrieve relevant documents. So this function assumes that a user is going to come to you with a query, which is basically asking about anything that could or could not be in your database. So that's the first parameter here, the query of the user. End results is how many chunks do you want to be returned, like the maximum number of chunks that could be returned. In this case, we're setting it to 5. And then threshold is related to the similarity metric. So remember, we are using cosine distance, which means the lower the better. So anything lower than or equal to 0.3 will be returned, and anything higher than this we will consider it to be irrelevant. 0.3 here is just the default. You can pass whatever threshold you'd like. So yeah, the function is actually very easy. The first thing we have to do is to embed the query. So the user query, we have to embed this. And for this, we are using the embed documents function that we created in the first script. And inside this, we are using the same embedding model, and that's very important. Whenever you're doing retrieval, you have to use the same embedding model that was used when storing the data. So now we have an embedding for that query, and we'll be calling the ChromaDB's query function. We will give it the embedding and yeah, the number of results. And we will give it what things it should include in the response. So it should include the documents, which is actually the chunk text itself, and it should return the distances, which is the cosine distance calculated for each of these chunks. So we know how much relevant or irrelevant each chunk is to the user query. And now remember that we talked about inserting metadata. If we had done so, we would have the option to include metadata here as well. So we could have made the DB return other metadata for us along with the chunks and the distances. And this is useful because you can use this as a filter. So imagine if I know that one query or the relevant information for a specific query is existing in a specific publication. Then in this case, I can filter these results based on that publication only. Like I can tell the DB only return chunks from that specific publication because I know that the information is inside this publication. In this case, we are not going to be able to do this because we did not store metadata. So whatever chunks we will get, we don't know where are they coming from. So yeah, this part is for applying the threshold filter because ChromaDB doesn't do this by default, so I had to do it manually. So basically what this is doing is it's looping over all chunks. It looks at the distance between this chunk and the query embedding, and if it satisfies the condition, if the distance is lower than the threshold, then we keep it, otherwise we don't. And here we are doing distance less than threshold because we are using cosine distance, which is the lower the better. If we've been using cosine similarity, then you would have to flip this. Yeah, so that's it about retrieving relevant documents. And let's take a look at how we can pass this to an LLM to generate an answer. So let's look at the respond to query function. So the first parameter is the prompt configuration, and I'm going to show you what this is in a moment. Also, it takes in the query, so it takes a query from a user and it tries to respond to that. which LLM are we going to use, and these parameters which are specific to the vector database. How many chunks do we want to return, and what's the threshold? So the first thing we do is we call the retrieve relevant documents function, which we defined here. We give it the query and the other parameters, and it's going to return to us some relevant documents. I'm just doing this for logging because everything will be logged to a log file that we have here, so don't worry about these. And I'm having a variable here called input data. So this is something that the LLM will see. So I'm telling the LLM the relevant documents are these, and the user question is the query. So this is the input data, which will be given to the LLM. We actually covered the build prompt from config in week 1. So I'm not going to go through it. However, I'm going to print to you how does the RAG assistant prompt look like. So we will see together how this prompt looks like. And then, yeah, we are defining our LLM. For this, we are using Grok. And the LLM we will be using is Llama 8 billion. And yeah, we send this prompt to the LLM and we get the response. So let's look at how the prompt looks like, and let's look at the prompt configuration parameter here. So whenever you're working with prompts, you should try as much as you can to write prompts that are reusable, prompts in which you can just inject data, and try as much as you can not to write these prompts in your Python files. So ideally, they should be in some kind of a configuration file. And in this case, we write all our prompts inside this prompt config file. So if you look inside, you'll see that it has 3 different prompts. And these prompts we use for this lesson and other lessons, but for this one, I'm going to expand this because this is the prompt that we'll be using. So yeah, it contains a description, a role, which is the system message, style and tone, instructions, some constraint we put in the output. So the LLM is going to see this entire thing. And we don't put it in our Python file, instead we put it in this configuration. So what happens here is we have written a function, load YAML config, which takes in the path for this file, and it just loads it as a Python dictionary. And then when it loads this entire file, right? But we are not interested in the entire file. We just need this RAG assistant prompt. So from that config, we take the RAG assistant prompt here, and this is what we pass as the prompt configuration to the respond to query function. So it actually sees this prompt. So whenever you want to change this, it's actually very easy. You can pass whatever prompt you want just by changing this this name here. You don't have to keep changing prompts inside your Python code. So yeah, that's about the first configuration file. So the second one contains a lot of parameters. Some of them we use in this lesson, some of them we don't. But for example, the LLM that we'll be using. So here we say we're using Llama 3.1 8B. And you can change this to be literally any model that Grok supports. You don't need to change anything in the code other than the LLM name here. And we are defining the default parameters that we'll be using for retrieving data from the DB. So yeah, here we have the LLM and vector DB keys, and we are again we are loading this configuration. We are taking these parameters and we are passing them to this function. So yeah, that's it about the code. Now let's do a quick demo. We will ask some questions and see how the LLM responds. So we will try and ask our RAG system some questions and see how it responds. And before we do this, let me actually show you some of the publications we'll be working with to give you some context on the questions that we'll be asking. So for example, this is a publication about variational autoencoders. And you don't need to be familiar with what's a variational autoencoder, but we will be asking this question, which is, what is a variational autoencoder? And we'll see how the LLM responds. So you can see we have an abstract, we have an introduction. So looks like the introduction contains the most amount of information about a variational autoencoder. So we hope that when we ask this question, maybe these chunks get retrieved from the DB. So yeah, let's see. So for this, I will run this script. And yeah, it says enter a question, config to change the parameters or exit to quit. So we'll just enter a question as a first try. So let's say, what are variational autoencoders? So you can see it's retrieving documents from, it's retrieving documents from the DB. It's embedding the query, this one, what are variational autoencoders, and then it compares this query with the chunks that we have in the database, and it returns the most relevant ones. So let's look at the relevant documents. So you can see it starts with this note about the MNIST images, and then a section called understanding variational autoencoders, which when you look at the publication itself in Markdown, it's this part here. It starts from here and goes down. It takes in these sections, which are okay. These sections are also about variational autoencoders. It actually describes the architecture of the model. It says that it has an encoder, a latent space, and a decoder. So it's good. I expect that the model is going to give me an answer that is acceptable. But you can see this part was not retrieved, the introduction. So yeah, let's take a look. So this is the first retrieved section. This is another section, and we're using 5, so it's going to return 5 different sections. Here's another section that mentions variational autoencoders, but it has nothing to do about the definition of it. So yeah, now the user question was, what are variational autoencoders? And here is the prompt that the LLM sees. So we are passing the entire prompt that we showed in the configuration earlier, and we are passing in the relevant documents and the user question, and then yeah, the LLM responds. Variational autoencoders are a class of generative models, and yeah, etc. So yeah, and it mentions the 3 components of the variational autoencoder, which is actually coming from the publication here. So you can see it is working. It is providing you with an answer from the publication itself. However, sometimes you might be expecting certain things to appear, like the introduction, but they don't. So one way we can work around this is to change the configuration parameters, which are these. So you can try higher threshold, meaning you allow more chunks, or you can try higher number of results, meaning you don't just use 5 results, you use more than 5. That's also okay. So this might give you a chance that these chunks might appear, but it also means you might continue to see things that are irrelevant. So use these things wisely. And the other thing that you might try is actually a better embedding model, because remember, this is the smallest, well, not the smallest, but it's one of the smaller models out there, because the embedding size is close to 380. You can try something where the embedding size is more than 700, or you can even go to 1,000 or 1,500, something like this. So this might actually help you. But yeah, remember that we are working with one of the smaller model out there. The second thing I wanted to show is, what if I type in a query that has nothing to do with all of my publications? So in this case, I'm going to try something like, what is linear regression? And I know that all of these publications has nothing to do with linear regression, or the definition of linear regression. So you can see the relevant documents are actually empty. It did not retrieve anything, because nothing here is related to linear regression. And yeah, the prompt that was sent to the LLM contained actually empty relevant documents. And then yeah, the LLM says, given that there are no relevant documents, I'm unable to answer the question. And the reason why the LLM did not answer from its own knowledge, if you check the prompt configuration here, we have in the output constraints these 2 points. So only answer the question based on the provided documents. If the user's question is not related to the documents, you should not answer the question. So if you don't include these things here, the LLM will actually try and answer this question, as it's very easy to answer. So we don't want to do this. We want to make sure that the LLM responses are grounded into our publications, and that's why we added these 2 instructions. So let me see what will happen if I change the parameters of the database. So I asked the question, no documents were retrieved. So this time I'm going to type in config. So it's asking me to enter the retrieval threshold. And the threshold that we are using was 1.5. I'm going to try something higher, like, sorry, it was 0.5. I'm going to try something higher, like 1.5. Meaning I'm allowing more documents to be retrieved. And for the top K value, we were using 5. Now I'm going to make it 10. And let's see if this affects the retrieval process. So I'm going to ask the same question. What is linear regression? Okay, so yeah, we changed the parameter, we asked the question. You can see this time there is some relevant documents retrieved. And this is because we increased the threshold and allowed more chunks to be retrieved, even if they are not that similar. And by looking at these, I can tell you this has nothing to do with linear regression. So you are just passing a lot of inaccurate information to the LLM, or a lot of well, not inaccurate, but I mean things that are irrelevant to your query. So let's see how the LLM responds. The question is not answerable given the document. So yeah, it thinks that these documents has nothing to do with linear regression. So the point here was to pick these numbers wisely, because you don't want to allow a lot of irrelevant data, because this is costing you money if you're using an LLM provider. That's one thing. And the quality of the responses are not going to be good if this data is irrelevant to the query. But you don't want it also to be very low, to the extent that you just retrieve 1 or 2 chunks. You want, as much as you can, that all of the relevant chunks, you want them to be present in the results. And you might allow some of the irrelevant ones, that's fine, but it shouldn't be never the case that most of the retrieved documents, like 80% of them, has nothing to do with your query. This actually means that this threshold is not set in the correct way. So before I end this video, I want to say that what we have done here is the simplest kind of RAG that you can ever build. And there are a lot of RAG variations out there, like graph RAG, Agentic RAG, and others. So feel free to explore these variations and pick whatever works the best for you. So this is what I do personally whenever I'm working on a project. Sometimes I just start by this simplest kind of RAG, because it's a general good thing to do, which is start with the most basic thing and then see if it works. If it doesn't, then try to explore other variations and see which one of them should work in your case. So yeah, that's it for this video. I hope you found this useful, and I'll see you in the future. Take care.